Hi, welcome to today's video about MOXIE. That's a device for the oxygen production on Mars. In this picture you can see the MOXIE. This name means Mars Oxygen In-Situ Resource Utilization Experiment. In-Situ means in place. This is an experiment for the oxygen production on Mars by electrolysis. This device is a part of the Perseverance rover, which landed on Mars in the year 2021. This is a picture of the MOXIE in a vibration test. Its size is 24 by 24 by 31 centimeters. It has a weight of 15 kilograms. And what is important about this experiment is that it is scalable. Its mission is to produce 6 to 10 grams of 98% pure oxygen in 1 hour. And it has to do that a total of 10 times. This is a short movie of scientists lowering MOXIE into the Perseverance rover. This is a MOXIE instrument installed in the Perseverance rover. This is a solid electrolysis cell from hydrogen production. MOXIE has a similar cell. It's a solid oxide electrolyzer made of ceramic zirconium dioxide. Here you can see the chemical reaction. 2 carbon dioxide molecules are reduced to carbon monoxide as oxygen. So carbon goes from oxidation state to +4 to +2. You need 800 degrees Celsius to make this reaction. But you don't want a further reduction to carbon, because for this you need more energy. And there's a problem with the carbon poisons the catalyst. And the power consumption of MOXIE is 300 watts. This is an artist concept of the Mars Perseverance rover. And now we know the MOXIE device works in Martian conditions. It has produced 12 grams of oxygen per hour. This is a picture from the first oxygen production test from the year 2021. This test was successful, as you can see here. But MOXIE needs to work at different temperatures. For example, average temperature is -65 degrees Celsius on Mars, and different conditions, for example, during the long dust storms on Mars, and it has proven that it can do that. This is another nice artist concept of the potential Mars city. Oxygen is needed for breathable air and as an oxidant. You can see you need a modular structure of the domes. This gives you more redundancy. And in my opinion, each dome should have at least 3 exits for safety. This is an artist's illustration of the SpaceX Starship at Mars. The propellant methane, CH4, can be made by the Sabatier reaction from carbon dioxide. And the oxygen you can get from a bigger version of MOXIE. The carbon monoxide is also important. Together with hydrogen from electrolysis of water, you have synthesis gas. This can be used for production of iron from ore. And another important compound is ammonia. You can use the Haber-Bosch process to produce ammonia from nitrogen. And this is important for production of fertilizer. The Haber-Bosch process was one very important discovery in the early 20th century because of the importance of the compound ammonia. This is a short movie of the Mars InSight lander of its robotic arm. The Martian soil contains 0.5 to 1% toxic perchlorate, ClO4-. That's why you need an extra step. That's you need to rinse the soil, or you need a reduction of this perchlorate, and you can use the soil for agriculture. This is one example of a robot. It's a Tesla Optimus robot. I call this a future Mars worker. And the combination of these factors, the progress in computers, artificial intelligence, new materials, and robots, make a Mars mission seems possible. And these robots like the Tesla Optimus or Boston Dynamics robot could be an advanced party for a future Mars colony, and they could be big helpers for science. This is a nice picture of terraformed Mars. Again, another artist's impression. The early Mars could have looked like this before it has lost its atmosphere, because Mars does not have a global magnetic field. And in the middle, you can see this Valles Marineris, this canyon system with a length of over 4,000 kilometers. Terraforming Mars is a long-term project, and if you want to have a dense atmosphere of Mars, you need one more thing. That's the magnetic shield at the Lagrange point L1, because you don't want Mars to lose its atmosphere. Even if you manage to terraform Mars, this is not an alternative to Earth. We need still be careful, and we need to also protect Earth. This is a beautiful picture of the frosty sand dunes in the northern plains of Mars. There's another very beautiful blue dune in the Lyot crater of Mars. This is an enhanced color image. And this is a MOXIE boy. This is a logo from the year 1911. MOXIE boy is from my ad for a soft drink in America. And that was today's video about MOXIE and the oxygen production on planet Mars. Thank you for watching. Have a nice day. Bye-bye.